Hi everyone, this is the second video relating to lesson 14 of Forces in Space, which is on terminal velocity, and this is just showing how I would model an answer to this piece of extended writing, this question that wants a longer response. So previously we drew this diagram, and what's important to notice from this diagram is that this gives a really clear structure to how we want students to write. So I'm going to start here, and I'm going to start with the sentence when the speed is low, and I'm going to relate it to what I see here. And what I want students to recognise firstly is that when the speed is low, the drag force is also low. So that's how I'm going to start my paragraph. Now, I should have said before I get straight into it, we're explaining here what that means is cause and effect. So the way I'm going to link together my ideas here is through cause and effect, and the kind of phrases that I'm going to use are going to reflect this idea that in science, when I'm explaining, I'm saying this happens, therefore this happens, consequently this happens, as a result this happens, really showing that chain of reasoning that goes on. So that's just an important thing to note. And I'm not going to go into the overall cause and overall effect here, because I just want to, it's Key Stage 3, I just want to get students writing. So I'm going to say when the speed is low, comma, the drag force is low, full stop. So the next thing I want to do is just continue along in my story. So if the drag force is low, what that means is I get this large resultant force. I've made up a number here, 650 newtons. So how am I going to link together these ideas causally? I'm going to use one of my favourite phrases for causal linking, which is this means that. This means that we saw is that there is a large resultant force. And I'm going to model this really explicitly to students, say I've used that phrase because this is an explained question. So I could have used therefore, or consequently, or as a result, or so, thus, and so on. But I like this means that, so that's what I used here. And again, the way I've laid out my diagram is really supporting student thinking. So this means that there's a large resultant force, which I sketched here. I might say, consequently, the parachutist accelerates rapidly. And actually, depending on the class, I might not even have needed to write that down, because if they're familiar with my the way I represent acceleration with this double-headed arrow, actually I could have just left it at that. But again, I've put it here and that's fine. So I'm going to say consequently, the skydiver accelerates rapidly. And again, I'm going to keep emphasizing that I'm using these causal linking words because it is an explained question, and that's what scientists do when they're explaining. They're linking things in terms of cause and effect. So consequently, the skydiver or the parachutist, either's fine, accelerates rapidly. Full stop. Then, and hopefully you can see here how the diagram really supports student writing. So I've gone through this line, then we said we got to here, and this is where I'm going to now write a sentence linking the fact that it's accelerated and the speed is increasing to this increase in the drag force. So I'm going to say as, that's another nice way, if they're not as sentences are also quite good, as the speed increases, comma, the drag force. Again, you can just work your way along. If you've got a group that's quite confident. You could even start getting them to do this on whiteboards themselves, because we're just working our way through now. So I'm going to say this means that the resultant force is smaller. This means there is a smaller resultant force. And I won't turn over to show my diagram, but you in the classroom will want to keep referring back to that. But the next thing we said was that caused the acceleration to decrease. So I'm going to write consequently. And again, that consistency there is going to help really scaffold students' thinking. Consequently, the acceleration of the skydiver decreases. Or you might want to say something like, just to avoid that misconception, you might want to say the skydiver continues to accelerate but less rapidly than before. And then we can finish off. I will go back to the diagram here. So we might say at a certain speed, and then we need to describe what's happening here, the drag force is equal to the weight. So that's the value of these diagrams that we do in the beginning of the lesson, is they really structure students' thinking. And it is just kind of following the story that we told through our diagrams. So at a certain speed, comma, the drag force becomes equal to the weight. I've used becomes, and again, if we're going to really make our thought process explicit, that word becomes is showing that the drag force kept increasing, kept increasing, kept increasing until it became equal to the weight. It's a very kind of subtle point, but you might want to draw students' attention to it. I'm going to put, this means that, keeping exactly the same structure and exactly the same causal linking phrases, this means that I'm going to put there is no resultant force consequently, the skydiver no longer accelerates. And again, we're just following that same pattern. The way that diagram's laid out is very deliberate, just following the same journey through. And then I might want to add a note here. Again, this is kind of for exams, but also it's useful for getting students to be really, really clear about that link between no longer accelerating and a constant speed. So I might say, therefore, I'll use another linking word which implies causality. Therefore, the skydiver travels at constant speed final note. This is called its terminal velocity. So the purpose of this video was not for me to show off how much I know about terminal velocity. The purpose of this video really was to show two things. One, how the layout of the diagram links directly to the way students write their answers. And actually, if we think really, really carefully about our diagrams, they can be really helpful in scaffolding and structuring students' thoughts and how they turn that into writing. Secondly, I think it's useful, especially for exams, but then it kind of comes back to our guest-deduced check model, is that when we're explaining things in science, what we're doing is building up from certain models and using those models to give really clear explanations of why these things happen. And in this case, our models are to do with resultant force and that link between resultant force and acceleration. like I say, this is a really, really good question because it comes back to the core concepts we've been addressing all the way through this scheme of work. And that's why I think it's worth having students think about it in depth and practice it. This example, and then there's, as you'll see, a couple more examples which are almost identical. And if students can really think about those and visualize the forces and see that link between the forces and the motion, we can be pretty confident that they've got a good handle on those core concepts, ready to put some math to them and do some equations at Key Stage 4 and 5. Next lesson, we'll look at vertical motion.